So 4.1 is about anti-differentiation. Basically, this is just the opposite of everything we have done so far. So there's no more derivatives we're going to do in this class. We're going to now looking at chapter 4 and 5, which is the opposite of derivative, which is the anti-derivative, anti-differentiation, or otherwise known as integration. We're going to kind of make up some of these rules as we go along. It's probably easier to understand. And the symbol for the antiderivative or integration is like this long S here. Now, if you think about, let's go back to derivative. What would the derivative of 3 be equal to? Zero. I agree. How about the derivative of -5? Zero. How about the derivative of 2.789? Zero. How about d by dx of 23/5? Zero. No, I think it's fair to say, Samira, that the derivative of any constant is going to be equal to 0. You agree? Doesn't matter if it's positive, negative, fractions, decimal. As long as it's a constant, it's going to give us 0. It stands to reason then that if we take the integration of 0, what are we going to get? If you go backwards, we're going to get a constant. We just don't know what a constant is, right? So when we take the integration of 0, we get a constant. It is a C. It doesn't look like a C. My bad. Okay, erase it. All right, does that look better? Oh, that doesn't even look that good either. So we use the letter C to represent that 0. So that's kind of one of the first fundamental rules of integration. Now let's look at d by dx of 3x plus 2. What's the derivative of that? It's 3. And it's actually 3 plus 0, you agree? Which is just, we do d by dx of -5x plus 1/2. -5 plus 0, which is -5. I mean, we could, do this all day, d by dx of 2.5x minus 1.8. What would the derivative of that be? Now that you can't see it. There you go. What's the derivative of 2.5x minus 1.8? 2.5 plus 0, which is equal to 2.5. All right. So So those are the derivatives, right? This is going back to like chapter 1. Now we're going to go about this the opposite way. Let's say we take the integral of 3 with respect to x. So this dx is telling us that, and it's known as a variable of integration. When we take the integral of 3, what are we going to get? Partially correct. So let's kind of back up here. Let's say this was, you know, a constant or a constant. It doesn't matter which constant is it, right? When we take the derivative of 3x plus a constant, it becomes 3. When we take the derivative of negative 5x plus a constant, it's negative 5. When we take the derivative of 2.5x minus a constant, it's just 2.5. So if we take the integral of 3 going backwards, what's the integral of 3? If we're going backwards, shouldn't we start with the origin? Shouldn't we have the original problem? 3x. What else? Plus the constant, because we don't know. Very good. How about if we take the integral of negative 5 with respect to x? What is that equal to? Negative 5x plus c. How about the integral of 2.5 dx? (2.5) what? You're missing something there. X plus c. Right, Samira? You wrote an X. Okay. That's fine. So here's a rule then. If we take the integral of a constant, so this is k as a constant for a number. What do you think the answer would be? Y squared? Not understand. When we took the integral of 2.5 here, it became 2.5x. When we took the integral of negative 5, it became negative 5 times x. Why did it just become squared then? So if you take the derivative integral of any constant, it becomes a constant times x plus c for the 0. So this is that rule. Where k here represent, a real number. not equaling to 0. Why it's not equal to 0? Because this constant here is when, you know, we're finding an integral of 0. That's why. So let's look at a couple of examples. So if we have the integral of negative 6 dx, what is our answer going to be? So this is our k. So what is our answer?
Negative 6x plus c.
Negative 6x plus c. So if you have a number just by itself, it just becomes that numbers times the variable plus c. How about the integral of negative 4 dm? What is that equal to?
Is it negative 4 m plus c?
Excellent, negative 4m plus c. You see, that's what the variable is telling. This variable of integration tells us which variable we're going to have into the problem. So it's negative 4m plus c. Ready to move on? So we have 2 rules so far. But by far, this is the most important one we have looked at. Let's develop another rule. So if we have d by dx of x to the third, what's the derivative of that? It's 3x squared. How about if we have d by dx of x to the fourth? For x to the third. And look at one more. D by dx of x to the fifth. Five x to the fourth. Very good. Now it's time to reason then that if we take the integral of 3x squared, Lois, what's 6 to the third? Okay. If we take the integral of 3x squared dx, what are we going to get?
X to the third.
X to the third. I agree, because we're going backwards, right? When we take the derivative, we went this way. When we take the antiderivative, we're going back that way, right? So this is, you know, antiderivative. And this other way is a derivative. So it should be x to the third. Now the question is, and of course, Jenny, there's always going to be that plus c on it. We'll come back to that. Every time we take an antiderivative, we're going to have that plus c there for now. And if we take the antiderivative of 4x to the third, what are we going to get? X to the fourth. I agree, because once again, we're going backwards, right? So this is going to become x to the fourth. About the antiderivative of 5x to the fourth dx. Thank you very much. X to the fifth plus c. And I agree with you on all these answers. But what we're trying to do now is let's look at this and see how do we go from here to here without knowing what's on the left side. Imagine the left side wasn't there. How do we go from x to the second to x to the third? Or x to the third to x to the fourth? Or x to the fourth to x to the fifth? What does it look like we're doing?
It looks like you're just replacing the exponent with the constant front.
For this problem, true, it does look that way, but that's not generally true. Let's see. And it's only because there was nothing in front, because let's say then we have d by dx of 5x to the fifth. You agree that would be 25x to the fourth, right? Right? All right, so the integral of 25x to the fourth dx would be equal to 5x to the fifth plus c. So you see, we're really not just replacing the exponent with a coefficient. What's happening to the exponents in all these problems? So initially the exponent was 2, then it became 3. Initially the exponent was 3, then it became 4. Initially the exponent was 4, then it became 5. It is increasing. How is it increasing, Myrta? By 1. And if you think about it, right? When we do derivatives, what do we do with the exponent? We subtract 1. I agree. So if we're doing the antiderivative, it stands to reason that we're going to add 1. Does that make sense? Because we're doing the reverse process. So every time we take the antiderivative, we're going to add 1 to the exponent for these type of problems. Right? All right, so that gets us to x to the third. Now, what happens to the 3? Because we still have a 3 here. How did we get rid of that 3? Or the 4, or the 5, or the 25? Because those disappeared. Let's go back to derivative again. When we take the derivative, what did we do first? What's the first thing we did? Let's take this problem right here. When we found the derivative, what's the first thing we did? Come on, you guys all told me that you multiply 4 by the x. Very good, right? So we take this 4 and we multiply by here. And then we subtract 1 from the exponent. So if we're multiplying in derivative, what should we be doing in antiderivative? We're going to divide. There you go, which is exactly what we're doing, right? So let's look at this last problem here. The 25x to the fourth dx. If you add 1 to the exponent and we divide by the new exponent, which is 4 plus 1, do we get the corresponding answer over here, which was the original problem? Yes. So that's the rule, right? So if I can cut this one and move it down here too. That's what cuts. I don't want it. But here it goes. I will just copy it down here. It says the integral of k dx is equal to kx plus c. No, it's actually here. Duh. So that's the first rule, but this is the rule we're just looking at. It says we have x to the n dx is equal to x to the n plus 1 over n plus 1. So it's saying the integral of x to the n dx is equal to x to the n plus 1 over n plus 1. So we add 1 to the exponent and we divide by the new exponent. And of course, this is still plus c. Now notice for this, there's an important note here that n cannot be equal to -1. This is when n is equal to -1. So when n is equal to -1, that's the natural log function that we did before. So this is the only exception to that rule. And of course, we look at the exponential function. So these are the 4 rules that we need to know for, most of this chapter. All right, let's look at a few examples from this. We won't do too many from your homework. 4.1, this is actually number 1. 14 questions in the homework. Number 1 says find the integral of 7 dx. And let's call these rule number 1, rule number 2, rule number 3, rule number 4. So which rule are we using for this? 1, 2, 3, or 4? Rule number 1. So what's the answer then? Seven x plus c. Let's look at number 2. It says find the antiderivative of x to the 2 over 7 dx. So which rule? 1, 2, 3, or 4? Number 4. Now be careful. This is not an exponential function. Because we don't have e in there done. Okay? So for use rule number 4, we have to have something like e to the 5x, e to the -6x. The base has to be equal to e. That's when we use rule number 4. What is the base in this problem? X, the base is x. So when the base is equal to e, this is rule 4. Here, this is our base. This is equal to x. All right, so rule number 2. So what are we going to do? We're going to add 1 to the exponent and divide by the new exponent, which is 2 over 7 plus 1. And your scientific calculator should be able to, really help you with this. So this becomes x to the, what's 2 over 7 plus 1?
Nine over 7.
9 over 7. I agree. So this is 9 over 7. And we're also going to divide by 9 over 7, right? Because that's good. And when you divide by a fraction, what do we do with it? We multiply by the reciprocal, so it becomes 7 over 9 x to the 9 over 7 plus c as our final answer. Let's go number 5. So the integral of dx over x to the 6. What do we have to do with this? So just like with derivatives, if this was a derivative, what would you do? Come on. If this was a derivative, what would we do?
You would rewrite it?
We would rewrite it. You're going to have to do some of the same thing in integration, right? So this becomes x to the negative 6 dx. If it's a square root or it's a radical, you have to rewrite it also. Because this previous problem here, x to the 2 over 7, could have been given to you as the 7th root of x squared, right, dx. They expect you to rewrite it first. No, which rule are we going to use? Number 1, 2, 3, 4. Number 3. Why number 3, Don? What is our exponent in this problem?
6.
Negative 6, right?
6.
When do we use rule number 3? When our exponent is equal to what?
Negative 1.
Negative 1. So this is the only time we use rule number 3, when the exponent is equal to negative 1. So that means we're going to go back to rule number 2, which means we're going to add 1 to the exponent and divide it by our new exponent. So this becomes, not that, becomes x to the negative 5 over negative 5 plus c. Don, you okay with that?
Yeah.
All right, let me help you. Number 6. So if we take the integral of 12 over x dx, let's rewrite this one. What does this become?
12x negative 1.
Very good. I agree with you. 12x to the negative 1 dx. Now, which rule are we going to use? See, this is when we use rule number 3, because the exponent is equal to negative 1. Right, which is what you're saying here. If we have 1 over x, then it becomes a ln of x. But this is only when the exponent is equal to negative 1. So all of this here becomes a ln of x. So the answer is 12 ln of x plus c, which is what rule number 3 says. The integral of 1 over x, which is the same thing as x to the negative 1, is equal to the ln of x. Let's go number 8. Says the integral of e to the negative 2x dx. All right, which rule? What's our base in this problem? Our base is e, right? And if our base is e, we're going to use rule number 4. What does rule number 4 says? It's 1 over a times e to the a over x. So again, you guys see that? Let's make it a little larger. So when we take the integral of e to the ax, that number in front of the x, we're going to divide the problem by and keep the e to the ax. So what is our a in this problem? Negative 2. So this becomes 1 over negative 2 times e to the negative 2x plus c. That's it. We just divide the problem by the a. That's how rule number 4 works. All right, I'm going to stop here. We'll continue this next class on Wednesday. So we do meet here on Wednesday.